Water worlds are surprisingly common in our galaxy, but they probably don't look like you think they do. A new type of exoplanet has been discovered around the most common stars in the universe, which may have significant implications in the search for life in the universe. Hi guys, welcome back to Not Alone, your space buddy. Is it possible to live on this planet? If so, how will life exist on those planets? Let's find out. Before that, if you're new here, don't forget to subscribe to our channel and hit the bell icon, which is completely free. So, scientists have listed thousands of exoplanets, or planets outside our solar system, in the 1990s. Some are massive and gaseous, while others are tiny and rocky, much like our own planet. However, a recent study suggests that some of these exoplanets may be denser and contain more water than previously thought, which has significant implications for alien life. Exoplanets are classified into 4 types: Neptunian, gas giant, super-Earth and terrestrial. It's difficult to spot these planets directly, let alone figure out what they're made of. One of the most tried and true methods of searching for exoplanets is transit photometry, which involves pointing a telescope at a star and measuring the light when a planet swings by. However, 2 astronomers, Rafael Lerchi of the University of Chicago and Enrique Palay of the Universidad de la Laguna in Spain, were interested in determining the density of specific exoplanets. In the new study, astrophysicists examined 34 exoplanets, of which they had precise diameter and mass data. These details helped the researchers in estimating the densities of these worlds and determining their probable compositions. Lerchi and Palay discovered that some exoplanets had more water than previously thought by crunching data about those 34 planets. According to the new analysis, these planets are roughly half water and half rock, forming a new class of exoplanets. Earth, on the other hand, is almost entirely rock and contains far less than 1% water, despite having a large amount of water on its surface. As we know, water is necessary for the continuation of life. Rafael Lerchi said that they can divide these worlds into 3 families in an interview with Space.com. They discovered 6 examples of a new type of exoplanet, watery, which is made up of roughly half rock and half water, either in liquid or ice form, with addition to 7 gassy planets and 21 rocky planets. Seeing evidence for so many water worlds orbiting the most common type of star in the galaxy was surprising, Lerchi said in a statement. It has huge implications for search for habitable planets. Previously, the concept of world so heavily saturated with water was previously the realm of science fiction. In a 1998 episode of Star Trek Voyager, the explorers visited a planet that was entirely made of water, resembling a spherical sea. Lerchi and Palay made this discovery by studying small transiting planets orbiting red M-dwarf stars. Red dwarfs are the most common types of stars, accounting for more than 70% of the stellar population in the universe. These stars are small and cold, around 1/5 of the mass of the Sun and up to 50 times brighter. Because red dwarfs are so common, scientists have discovered if they might be the best bet for discovering planets that can support life as we know it on Earth. In 2020, astronomers who discovered Gliese 887, the brightest red dwarf star in our sky at visible wavelengths of light, may discover a planet within its habitable zone where surface temperatures are suitable for liquid water. However, whether the worlds orbiting the red dwarfs are potentially habitable remains unknown, due in part to researchers' lack of understanding about the composition of these worlds. Previous research suggested that small exoplanets, those with a diameter of less than 4 times that of Earth orbiting sun-like stars, are either rocky or gassy, with either a thin or a thick atmosphere of hydrogen and helium. The new study sought to investigate the compositions of exoplanets orbiting red dwarfs. They concentrated on small worlds, discovering nearer, brighter and easier to inspect red dwarfs observed by NASA's Transiting Exoplanet Survey satellite TESS. Because stars are much brighter than their planets, most exoplanets are invisible to astronomers. Exoplanets are typically discovered through the effects they have on their stars, such as the shadow cast when a planet passes in front of its star, or the tiny gravitational tug on a star's motion caused by an orbiting planet. Scientists can determine the diameter of a planet by capturing the shadow cast when it passes in front of its star. Researchers can determine the mass of a planet by measuring the small gravitational pull it has on a star. According to the scientists' planetary formation models, the small planets they discovered evolved in 3 ways. The rocky planets are thought to have formed from relatively dry material close to their stars. Because the density of the small rocky planets is nearly identical to that of Earth, their compositions must be very similar. The watery planets, on the other hand, most likely formed from icy material and were born far from their stars, beyond the ice line where surface temperatures are freezing. They eventually migrated closer to where the astronomers discovered them. Gassy planets are also water-rich and may have formed in the same way as watery planets. However, they had more mass at first and could thus gather a hydrogen and helium atmosphere around themselves before venturing inward. Although the rocky planets are relatively poor in water and the watery planets are abundant in it, this does not necessarily imply that the former are arid and the latter are covered in oceans, even though water covers 3/4 of the Earth's surface. Earth has only 0.02% of its mass in the form of water, making it a dry world from the standpoint of astrophysics, according to Paley. In contrast, although the watery planets discovered by the researchers are half water, that doesn't necessarily mean they have massive oceans on the surface. He also added the water appears to be mixed with the rock. Future research will look into these to see if these types of worlds can be found around larger stars. Lurkey explained a new generation of instruments in ground-based telescopes, particularly in the United States and Europe, will enable us to make these measurements in an interview. He also added, investigating the composition and properties of these watery worlds is another avenue to pursue. We can analyze their atmospheres, if they have any, and see how they store water with the James Webb Space Telescope. This will reveal a great deal about their formation, evolution, and internal structure. The universe may contain trillions of planets. So far, 5,172 exoplanets have been discovered, occupying 3,816 planetary systems, according to the Extrasolar Planets Encyclopedia. Planets are far more difficult to spot with telescopes than stars, which are estimated to number 200 billion trillion or 200 sextillion due to their comparatively smaller size and the fact that, unlike stars, they typically do not generate their own light. In comparison to the vast number of stars observed, 5,172 exoplanets represent a much smaller sample size. However, it's constantly expanding, and new discoveries about these other worlds are announced on a regular basis. Diamond rain, for example, may be common in some exoplanets, and 2 Earth-like exoplanets were recently discovered 105 light-years away. Do any of these exoplanets have life on them? Scientists have no idea so far. However, tools such as the James Webb Space Telescope will make it easier to determine what exoplanets are made of and whether they contain the necessary materials to support life. There are a lot of good contenders so far, but this new study could significantly add to that growing list. With this, here comes the end of the video. If you liked this video, don't forget to give it a thumbs up and also subscribe to our channel Not Alone for more updates in the future.